So we're going to write at the top of our notes, we're going to write, there we go. At the top of our notes, we're writing function operations. Function operations. So if you remember what operations are, it's like adding, subtracting, multiplying, dividing. Adding, subtracting, multiplying, dividing. All right, so we're going to start off kind of simple, and then we're going to kind of work our way up. So the first operation that we're going to go over is just addition. And I've got a few examples for you. I'm pulling these off the worksheet that the Sanders group is going to do. So Sanders group, I'm doing these off of your assignment, okay? So we're going to number them from the ones on your assignment, and then you'll know you don't have to do these again, okay? So we're going to start with number 1, 7j to the third minus 2 plus 5j to the third minus j minus 3. And what we're doing right here is we're adding two polynomials together. And this is going to feel kind of review. So if we add two polynomials together, what are you basically doing? When you add two polynomials together, what are you basically doing? Not multiplying. You're adding. You're combining like terms. So if you add two polynomials together, you don't really need the parentheses. The parentheses are just to say this is one polynomial, this is the other polynomial. But really what you're doing is combining like terms. So I say this is the cubed term of the first polynomial. This is the cubed term of the second polynomial. I look and I say, oh, this one's got 7 of them. This one's got 5 of them. So how many do we have altogether? Did somebody say it? 12. We got 12. So we're going to say this is 12 j to the third, okay? So I did the first term. There's no j squared. That's what would come next. What comes after that? No. We would have, we'd have j to the third, then j squared, then the j's, the plain j's. There's only one of those, so I'm going to write that next. So then we write negative j. And then after that, we do our plain numbers. We have a negative 2 and a negative 3, and what does that give us? Negative 5. Perfect. Okay, so that's our final answer. So addition is pretty simple because you're just combining like terms. So let's do one more of those. We're going to go ahead and we're going to do number 6. So we've got negative 4x plus 4x to the third plus 7 plus 3x to the third minus 9 minus 3x. All right. So what do we put first? What always goes first? Yeah, we would do the x squared first, or in this case, which one do we do first? It's bigger than x squared. Cubed. We're going to do the cubed first because it's the highest exponent. So we have a positive 4x to the third and a positive 3x to the third. So how many x to the thirds do we have? We got 7 of them. So 4 and 3 make 7. All right. We don't have any x squareds, so we're going to skip the x squareds. And then what do we have? We have plain x's. We've got -4 plain x's and -3 plain x's. -7 plain x's, okay? And then after that, we're going to look at just our regular numbers. So we've got a +7 and a -9. -2. Okay, so when you're adding, you're just combining like terms. That's all you've got to do. Okay, next, let's go ahead and do subtraction. Okay, so with subtraction, we'll start off, we'll do this one first. This is number 8. So number 8 says -x squared plus x minus 4 minus 3x squared minus 8x minus 2. And we have to be careful with this one. We cannot just start the problem without writing stuff. And does anyone remember why it's important to write some work down before you get started with subtraction problems? We have to do something before we start. Anyone know? It has to do with this. We're going to have to rewrite the equation because we have to distribute the negative. So with addition problems, you can just start combining like terms. That's all addition is doing. But whenever you're subtracting something, you have to distribute the negative, and then you can combine like terms. So I'm just going to take the first part, the first polynomial. I'm going to write that down. -x squared plus x minus 4. I don't need to do anything with that. But with the second polynomial, I need to distribute the negative. So negative of 3x squared would just be minus 3x squared. What happens when I do negative of -8x? Positive 8x. What happens when I do negative of -2? Positive 2. All right, and then now it's kind of like an addition problem. So what should I write for my first term? I'm going to do my x squareds. How many of them do I have? Yep, so -1 and -3 is -4x squared. Okay? And then 8 and 1 makes 9x. And then -2. Okay, next we're going to do number 12. Number 12 says 3x to the third plus 3x squared plus 9 minus 5x to the third minus 7x squared plus 6x minus 9. So I'm going to do the process just like I did the previous problem. I'm going to copy down the first problem, 3x to the third plus 3x squared plus 9. And then what should I do? Perfect. Minus 6x plus 9. Okay. And once we have all of the terms written out and we've changed all of the signs, then what do we do? Which term do we start with first? The cubed. So we're going to write negative 5x to the third first because that's the only one. So that one gets written first. Oh, no, sorry. There's two of them. Okay. So negative 5 and positive 3. Negative 5 and positive 3. Negative 2. So it would be negative 2x cubed. Thanks for catching that, Trevor. Negative 2x cubed. Okay. And then what? So 3 and 7 makes 10. So 10x squared. Okay. And then what do we have? Minus 6x. We truly only have one of those. Okay. Plus 18. Okay. How are we feeling so far? Good? Do we want to move on to multiplication or we just want to practice that? Just practice this? Okay. So I'm going to hand out this worksheet. You guys are going to work on the Sanders group. You guys are going to do 1 through 14. Does that sound okay? There's not room on the worksheet, so you guys are going to do it on a separate sheet of paper. Okay? So what you're working on is you're going to work on finishing your warm-up, and you're going to work on 1 through 14. The plan is you have to finish the warm-up, and then you're going to tell me how far you get on 1 through 14. Can we do that? We have to finish the warm-up, and we're going to tell me how far we get on 1 through 14. We're good? We know what we're working on? Yes? We can do that? Okay. Now you have to work silently because I'm going to keep doing notes with the group that's with me. Can you guys do that? Work silently? Okay. So let me get this all handed out. You have to write super small. Remember, I have to be able to read it, though. Oh, my gosh. Okay, don't make me hate my life. Okay. All right. My group. Are you ready? We ready? Okay. So we have... we're going to do kind of the same thing, but we're going to do something called function notation. Okay, so you guys are going to see the same operations, but we're going to see it with a slightly different notation, and we're going to see it with different types of functions. Okay, so we're going to see function notation. Yeah. Mm-hmm. Function notation. So with addition, you might see something like f of x plus g of x. So remember how when we were doing evaluating functions last week, how they would give you all the functions at the top of the page and then they would tell you what number to plug in? This is the same type of thing. They'd give you all the functions at the top of the page and then they'd say find f of x plus g of x. Or they came up with a shorthand, and the shorthand, it's not, in my opinion, it's not really a shorthand, but they do it anyway. They say f plus g of x. And all that does is it makes it so you only have to write the x one time instead of twice. So these two things mean the same thing. It just means you're taking whatever f of x is and whatever g of x is, you're just adding them together. But it's just two different ways of writing the same thing. It's just function notation. Okay? Okay. We could do, let's see. We could do subtraction. So this would be like f of x minus g of x, or it could be written as f minus g of x. You guys, we have to nose goes. Who wants to open the door? I don't know. Whoever lost. Who lost nose goes? Everybody. Everybody except for me. I'm the only one who doesn't have to open the door. Hi, Zia. All right. The next type is multiplication. So f of x times g of x, or they might write f times g of x. When you get high enough in math, they start to shorthand it even more. So they might just write f plus g. They might not even put the x, not even put parentheses, just f plus g, f minus g. They start to get lazier and lazier. Yeah. Okay. And then last, we have division, which is going to be, this one has the most different ways that it can be written because division can be written with the little division symbol, but it can also be written as a fraction. So we could say f of x divided by g of x, which means that if we were to shorthand it, we would just say f divided by g of x. Or we could do the version where we use the little division symbol. So we could say f of x divided by g of x, like that. And then the way you could shorthand is you could say f divided by g of x. So division has the most options for how you could write it. Okay. How do you guys feel about the notation? Are we good? Does it make sense? Okay. I did want to go over a multiplication example just because we didn't do one of those earlier, just to make sure we still remember how to multiply. So let's say that we had f of x was 3x minus 7, and let's say g of x is x squared minus x. And the instructions said to find f times g of x. Let's say that's what the instructions told us to do. So if I saw these instructions, the very first thing I would do is write it in a way that's more comfortable. So this notation to me doesn't feel very comfortable. I mean, it does for me now, but when I first started learning it, I didn't feel very comfortable with it. So for me, the very first thing I would do is I would say, okay, this means f of x times g of x. That's what it actually means. And then after I wrote down, okay, that's what it actually means, then I would write down the two different functions that I was actually multiplying together. So then I would say, all right, f of x is the 3x minus 7, and g of x is the x squared minus x. And you can notice that just like those examples that we were doing before from the other worksheet, I put each of the functions in parentheses so I can see what my first function is and I can see what my second function is. So if I'm adding, then I just get to ignore the parentheses. If I'm subtracting, I know that I should take the negative and distribute it. If I'm multiplying, then I have two sets of parentheses that are right next to each other. And what do we always do with parentheses that are right next to each other? We multiply them. And you can use the FOIL process if you're comfortable with foiling, or you can use the box to multiply. And I think at this school we typically use the box to multiply. Is that how you guys learned it? Would you guys rather FOIL, or do you guys want to use the box? What would you guys prefer? You guys care? You need batteries? Go ahead and grab one of the other calculators over there. Just trade it for now, and then I'll get you batteries. Yeah. Okay. Do you guys want to FOIL or use the box? FOIL? Okay. So we would do the first times the first. So 3x multiplied by x squared. What do we get for that? 3x cubed. And then we would do the outsides. What would we get for that? What do we get when we multiply the outsides? Negative, you're very close, negative 3x squared, perfect. And then we were going to multiply the insides. What do we get when we multiply those? Anybody? Negative 7x squared, perfect. Okay, and then we're going to multiply the last. And so if we multiply the last, what do we get? Positive 7x. Okay, and if we combine like terms, then our whole answer would be what? Three x cubed minus 10x squared plus 7x. Okay. All right, so I'm going to hand you guys the worksheet, and then let's practice these together. So the work isn't different than what you've seen before. It's just the notation at the beginning of the problem. So once we can get past the notation, then after that you go like, oh, I've seen this before. Okay, so I'm going to hole punch this and hand it out, and we will start at the beginning and just see how far we can get. See anybody there still. Yep. Oh. Hey, Liam. You can sit back there with that group. Hold on one second. Oh, you can use one of these. There we go. They're doing 1 through 14. Okay. So if you guys look at the problems, which one would you guys like to do together? Hang tight. You did your warm-up and you did the worksheet? Okay, hang on for a second. Which one? One? Okay. So it says f of x plus g of x. So we're going to go up here and we're going to find f of x and write it down. So f of x is 4x plus 2. G of x is x squared minus x. Now, if we're doing an addition problem, do the parentheses really make any difference? No. So with an addition problem, we're just going to kind of combine like terms. And so what should we write first? Which term do we always start with? The squared one. Okay, so I'm going to write x squared. And then what comes next? Plus 3x. Okay, and then what comes after that? Plus 2. Perfect. Let's do number 4 because we didn't do, or not number 4, let's do number 8. Number 8's a division one. It looks weird. We didn't do any division examples, so this will be a good one. So very first thing, I would rewrite the notation because the notation looks confusing. So I'm going to say, okay, this notation really just means q of x over g of x. No, I'm teaching. You're interrupting me teaching. All right, q of x over g of x. So all we have to do is we're going to write this problem exactly the same, but we're just going to replace the q and we're going to replace the g. So I'm going to write a fraction, and then q of x, if I look at the top, just says negative 2x plus 5, so that's all I have to write on the top. And then g of x for the bottom is x squared minus x. And we literally leave it right there. We do nothing. We stop. So the division ones, or division, we're kind of used to being intimidating. But for this particular assignment, the division ones are nice because we don't have to do anything. We're just done. Yep. So this problem is finished right here. Okay. All right, you guys want to find another one to try? Number 10? Okay, so this one says q of x minus m of x plus p of x. So I'm going to write q down first, negative 2x plus 5, minus m of x, so minus negative x plus 7, and then plus p of x. Okay, so I wrote them all down. Now what should I do? I have to do something with the minus, right? Distribute the minus. So the first one I can just copy down. And then with the minus, I can distribute the minus. And then what do I get after I distribute the minus? Plus x minus 7. Okay. And then what should I write for the end? Yeah, just plus 1/2. Would you guys rather write it as a decimal? Would that be better than a fraction? You want 0.5? Yeah? Okay. So if we start to put all of this together, we only have x's and regular numbers. So we've got negative 2x, 1x, 0.5x. Negative 2, 1, and 0.5. So what would that be? It'd be what? You're very close. It'd be negative 0.5. Yep, because the negative was bigger. So negative 0.5x, okay? And then what else would we have? Minus 2, yeah. Okay. So for you guys, our goal is going to be 1 through 10. Is that okay? Good goal, 1 through 10? Okay. All right, and we're going to leave it there. All right, Brayden, you can go to the bathroom.